In this experiment, I recreate the iconic Briggs-Rauscher oscillating reaction. In this reaction, two competing reaction mechanisms result in a reaction intermediate, in this case iodide ion, that oscillates in concentration. One reaction mechanism results in the concentration of the iodide ion increasing, while the other results in the concentration decreasing. Which mechanism dominates is determined by the concentration of iodide, and the reaction switches off between these two mechanisms. The concentration change of iodide is able to manifest as a color change because starch is added to the mixture. When iodide ion complexes with the starch, it forms a deep purple, blue, black color. In order to carry out this reaction, 3 mixtures are needed in equal amounts. 3 vials were labeled A, B, and C to hold these mixtures. Then I decided to add all the dry ingredients to the vials first. First, 0.65 grams of potassium iodate was added to vial B. Then 0.24 grams of malonic acid was added to vial C. 0.05 grams of manganese 2 sulfate was added to vial C. Finally, 0.01 grams of cornstarch was added to vial C. Then, wet ingredients were added. 15 milliliters of 12% hydrogen peroxide was added to vial A. This is the only component in vial A. Then, 13.8 milliliters deionized water was added to vial B. I'm not sure why I decided to add over 10 milliliters of fluid to something with a 1 milliliter micropipette, but here I am doing it anyway. Then 1.2 milliliters of 1 molar sulfuric acid was added to vial B. Vial B was then shaken to mix and dissolve the potassium iodate. Finally, deionized water was added to vial C up to the 15 milliliter mark, about 13.5 milliliters, and the vial was shaken to mix and dissolve things as best as possible. After this, all the mixtures are ready, and all that remains to be done is to mix them all together in equal volumes. I ran several trials where I mixed 1 milliliter of each mixture together to try and recreate the reaction. I found that during these trials, the results varied drastically in terms of color, oscillation frequency, and how long the oscillations lasted for. For example, in this reaction, we can see the mixture darkening, but not going purple. In this example, we see oscillations that are slow and do change color. Finally, in this example, we see the color change occur, but after only a couple oscillations, the reaction stops. This probably indicates that the Briggs-Rauscher reaction is very sensitive to its initial conditions. Indeed, in the original research papers on this reaction, they indeed found that this was the case. To get more consistent results, I could probably use larger volumes, and in that way, there would be less variation in the overall concentrations of the reaction mixtures. Anyway, thanks for watching.